All right, well, welcome everybody to the bittersweet moment that is the beginning of our last day of our workshop. It's been a really excellent week so far. We've got one more day to go. I notice the room looks a little less populated than previous mornings, but I'm sure people will trickle in. This morning we have sessions talking about looking forward, and then some workshop sessions in the afternoon. At lunchtime, we have a town hall, which will be here to discuss the steps that we might take towards advocacy for heliophysics. So it's a 1 hour time slot. I think there's maybe 15 minutes after the workshop sessions close before that town hall will begin. So you might be able to get some grab-and-go food. I think there's a grab-and-go stand in the Hilton, or there may be something here. But that will start at 12:15 and go for an hour. So we encourage people to participate in that. But other than that, I'll hand over to Christine, who has a couple of remarks, and then we will get started with our morning session.
Yeah, so today's plenary, if you looked at the schedule, is titled Heliophysics Looking Forward. And we had picked that theme before, actually quite some time ago, but I think it's really relevant now especially, and we're excited to hear from our speakers. First up, we have Robin and Stephen, who are going to come and give us a summary of the decadal survey that a lot of work went into, and also after we'll have a Q&A session as well. So Robin and Stephen.
Good morning, everyone, and thank you all who got up early to come here, and even those of you online who got up. So we're going to tag team this as we have in the past. We're going to try and keep this pretty short to maybe 20, 25 minutes, so there's a lot of time for discussion. But I did want to point you to the QR code there. The decadal release video of the full presentation is posted there along with the report and a lot of other information. So. We thought we would start with what is a decadal survey for, I don't know how many early career people made it here this morning, but we wanted to give a quick overview of what is a decadal survey. So the next time a decadal survey is, we have one of them. Many of you, the young folks, are going to be involved, so we wanted to give a quick overview. So this is their community-driven studies produced by the National Academies, but they really are community-driven, and they articulate a community consensus about the most compelling science questions for the decade ahead. And I think this is really important to remember. We make a lot of recommendations for types of missions and ground-based facilities, but it's really the science questions that are the core of the decadal survey. There was an early career webinar that the National Academies put together before our decadal survey was launched, so encourage folks to go look at that if you want to learn more. So why do they matter? So decadal surveys are mandated by Congress for NASA. Of course, our decadal survey was also sponsored by NSF, NOAA, and AFOSR, but NASA is required to do them, currently at least, and they do take them, Congress really does take them very seriously. If you look at appropriations bill language, you'll often see mention of the decadal surveys. And oftentimes you'll see Congress put things back into the budget compared to the president's budget request based on decadal survey priorities. Which is relevant right now. Also, every proposal we write, it's either very powerful or required to relate your research to decadal priorities. A lot of the programs we proposed to were recommended or came out of recommendations of decadal surveys. One of the jobs of a decadal survey is to identify gaps, opportunities that are missing that the community needs to be able to do the science. And last but not least, a lot of the data, of course, that we get from missions and facilities came out of decadal survey recommendations. And often it takes several decades to actually get the facility that was first recommended in a decadal survey. I think just looking forward, I think it's important for all of us to get behind the decadal survey and to talk about the importance of the science and the relevance of the science. And also mention that there will be hopefully a midterm assessment in 5 years. And the midterm assessments are very important for laying out the statement or motivating the statement of task for the next decadal survey. So it's something people should be thinking about, well ahead of the next decadal survey. All right. So this is the statement of task. We're not going to go through it in detail. We just want to remind folks that this statement of task, a lot of the differences in the statement of task for this decadal survey were a result of things that came out of the midterm assessment. And the statement of task is put together by the agencies along with the national academies, and any National Academy study really is defined by the statement of tasks. The statement of task is very important. It's what the report is reviewed against. So in this case, we had sort of the topics that are historically important for solar and space physics, but we also had a statement of task item on looking at new and emerging frontiers, and then also space weather. And that was important for us, I think, because it allowed us to sort of expand our decadal survey relative to the last one. So just a shout out to the steering committee and everybody who was involved, all the panel members. We had a great steering committee. That steering committee really reflects that broad scope of the statement of task. So we had folks on there with a wide range of different expertise, both scientifically and also programmatically. So, of course, the panels did the bulk of the work in processing the community input papers. So we had 5 panels on different regions of space, but also a panel on space weather science and applications, and a panel on the state of the profession. And then we had cross-cutting working groups that panel members were participating in. So this is really your decadal survey. The priorities in the decadal survey came out of 450 community input papers, questions that folks asked during the town halls along the way. And so it really is a community document. And you know, a lot of the workshops that were held prior to the decadal survey were also really important. All right, and the big button is the advance.
Big button, yes. Thanks. So the report is split up into, at least the summary, I should say, the steering committee report is split up into 6 chapters, and then the panel reports are in the appendices. And the 6 chapters are basically the current state of solar and space physics, and then science, then space weather, and then the state of the profession, and then introduction of the comprehensive research strategy that will achieve the science and space weather goals. And then finally, just a summary chapter, and that has the budget implications in it. The first chapter is a summary of the state of the profession, and it can be summarized in a few very select examples of the past decade of achievements. And my favorite, of course, not necessarily for GEM, but certainly for civilization, is exiting our heliosphere. That is a civilization-defining event, and we've done it twice now with the 2 Voyager spacecraft. Likewise, there's been tremendous accomplishments in space weather, and probably the most important for the decadal was the signing of the Pro-SWIFT Act, because this was a bipartisan effort and then signed by actually President Trump back then, signed by President Biden, but the Pro-SWIFT Act codifies the importance of space weather, and it was really the guiding structure for our space weather applications. And you can see from the graph on the left, the growing customer base that NOAA faces, and the red line is the number of satellites in orbit, and it looks like it goes to infinity around 2026 or so, but it can't. But bear in mind that just one collision from 2 satellites would create a dead band, essentially, where you can't put spacecraft anymore. I know that directly because I work on the Tracers mission, and we've had to choose an orbit altitude 3 times now. We finally settled on 590 kilometers. So the beginning of in Chapter 1, we introduced the vision and the mission, and we did this exercise to sort of consolidate what solar and space physics was all about. And the vision and the mission is summarized here. The vision is where do we want to be, not necessarily in the next decade, not even in the next decades, but somewhere out there in the future, where do we want to be? And it's to discover the secrets of the local cosmos and to expand and safeguard humanity's home in space. The mission is what are we going to do in the next decade and beyond to achieve this vision. And it really is a single sentence, and this is very important, is that science and space weather are inexorably linked, and you'll see that a little later on here. But in the mission statement is a single sentence. It's to explore our habitable cosmos, to discover and to serve humanity. And so you can say it as one thing, and we like to think of it as two sides of the same coin. There are 3 science themes underneath in Chapter 2. The sun, Earth, space, our interconnected home. This takes into account the combination of systems in our in the realm of solar and space physics, which includes the heliosphere, the sun, the magnetosphere, all the way down into the interior of the sun, and then all the way down into the ionosphere, thermosphere, mesosphere, and all the connections thereof. The second theme is a laboratory in space. It takes advantage of the fact that we have a laboratory out in space, literally just above our heads, where we can study fundamental processes that can't be studied in nearly the detail that we can study them, but that occur throughout the universe. And then finally, the third theme is new environments, exploring our cosmic neighborhood and beyond. It is, the picture there is of a comparison of Uranus's and Earth's magnetospheres, and that was, of course, identifying that the planetary decadal as their highest priority mission is a mission to Uranus, and we'd like to point out that that's a fascinating magnetosphere and a fascinating magnetosphere-ionosphere system. Within each theme, there are guiding questions, and this is an example of one. So the theme, Sun, Earth, Space, our interconnected home. How does our heliosphere function as a nested system? And then beneath the guiding questions, there are research focus areas, and this is where the progress is made in the next decade. And they are region agnostic. So if you read that energy and momentum flow across and within heliosystem parts, you can apply that anywhere in our heliosystem, and that's on purpose. So these are region agnostic, and the example we show there as the upper atmosphere, and the emission that you see there, of course, is GDC. In the theme laboratory in space, this is an example of the guiding question. How is the sun's global magnetic field created and maintained, and what causes its cyclic variations? And this is directly directed to one of our other recommended missions, and that is a flight over the poles of the sun to understand how the magnetic fields of the sun converge down into the poles. Finally, the theme of the new environments, as an example, focus areas, mass and energy flow processes, and that's driving planetary magnetospheres. And this is, if you've been around long enough, we used to call it comparative magnetospheres, but it's really comparative systems that we're emphasizing here.
All right, so with the science, we also had space weather themes. This is the to serve humanity part of our field, and the first one is system of systems. So you can think of these actually as the drivers, the responses, and then the impacts of space weather. So system of systems is what's driving space weather, the response of our system, and then the impacts on both humans and our technologies. So similarly to the science themes, we have focus areas for space weather, but these are a little bit different because of the applied nature of space weather. The focus areas are driven by outcomes. So we identified specific outcomes where we want to have improvements, for example, in predicting a shorter lead time for predicting a CME, for example. Of course, it's really important to emphasize that space weather and the basic, more fundamental research are integrally linked. And we really don't make progress on either of them without making progress on both. And of course, I think right now, space weather is going to be a really strong selling point for our science, and it is a really important part of what we do. And we, in the decadal survey, we looked at these as really two equally important parts of our field that are linked, and they're linked in particular through that system of systems, right? This is a system science, much of it, but we need to learn about fundamental processes as well in order to inform some of the system science and vice versa. So we also have a chapter on the state of the profession. I'm going to keep this short because Allison Janes gave a really nice overview of this chapter in the Decadal a couple of days ago, so I encourage folks to go look at her slides as well. But we really focused on how do we retain and attract talent and build a workforce for tomorrow. And that workforce needs to have a really varied range of different expertise and skills to do the kind of work that we need to do. So a lot of the recommendations are focused on building that workforce. We can't do science without the people to do the science, is kind of the main point. The Chapter 5 is a comprehensive research strategy, and we're not going to go into the details and the recommendations here, just to save some time for questions and discussion. But the decadal research strategy, we have recommendations in the state of the profession and the space weather chapters so that those would be standalone chapters, but everything comes together into a single strategy that encompasses all of that. And there are 3 parts to this strategy. The first is the Integrated Heliosystems Laboratory. This is an expansion of the idea of the NASA's HSO, the Heliophysics Systems Observatory, recognizing the importance of combining ground-based, space-based, and large computational models. These are all the things that produce data for us. And I think what we want to emphasize here is the importance of the assets we currently have operating. And it's really using all of those assets together and doing it in a strategic way, that we can really make the most of those investments. There's billions of dollars of investment flying in space and on the ground right now. And a lot of the science in this decadal survey really makes use of those existing assets. We, of course, made recommendations to fill a couple of major gaps, and some of those gaps really do need to be filled by large facilities and large missions. So we have mission concepts for NASA and both a large-scale and mid-scale recommendations for the National Science Foundation. The second part of this is Drive Plus. This is an expansion or enhancement of the Drive concept. This is all the research and technology programs, everything, how our research gets funded, supporting and developing a workforce, and the technologies. So that, in order to do the science, we need that to take the data and turn it into science. An important part of that Drive Plus is an improvement in cyber infrastructure. How do we take all the data from these different heterogeneous sources and really pull them together in a way where the community can really make use of them without having to continually reinvent the wheel or learn different systems. So I think a really important recommendation in there was related to that. And then last but not least, we have a chapter that looks beyond the decade. What can we be doing now in order to prepare for future decades? And some of these things we recommended are going to take longer than we were hoping, and that's always the case in decadal surveys, but we can still be making progress to march towards those goals in this decade. So I did talk already about the Integrated Heliosystems Laboratory, so I won't elaborate on this anymore, but just to drive home the point that this includes all NASA, NSF, international and NOAA assets. And I think, you know, when we tell our story about the importance of the work that we do, it's really important to emphasize that this is how we do our science with these existing assets. So we're gonna stop there to leave some time for discussion. I think it's important to remember that, first of all, the science is the most important thing in the decadal survey, and the recommendations, mission concepts that we have recommended are one way to implement that science. And so, you know, we're in a place right now where budgets might be cut, but we can be creative and think about other ways to implement the science. I think also there are some types of science and some things we can't do without big missions, and big missions also and big facilities support efforts that are smaller. So I think we need to continue to tell the story of how important these larger efforts are as well. But we, you know, it's really the science. This is a 10-year plan. I think it's very easy for everybody right now to be, well, none of it matters, perhaps, because of what's going on right now. But we just have to keep telling people about the importance of the work that we're doing, and remember that this is a longer-term vision here, and the science questions are important, and we need to keep telling people that story.
Yeah, and the last thing, too, is, again, to emphasize that the science and the space weather go hand in hand. And so you can't remove one or emphasize one without having the other. And that's another very important message to convey to your congressional representatives, to NASA officials, and in general, to the general public. So we'll advance it. There's a QR code there that you can pick up the decadal and open it up to questions.
The agenda allocates about a half hour for questions, so start asking.
Thank you for that. So to start out, the question I have is, some portion of this plan is predicated on the availability of large missions to enable us to implement a research strategy. One of the impacts probably of the current environment might be that the ability to support those large missions may be in question. So if you take that option away and then say, well, what could we do, how would this plan have to change if that major pillar of the plan has to be delayed? Does that make sense?
Mm-hmm.
Sure. So it's really important to emphasize that the cadence of the large missions is many years long, and so delaying them, delaying one or two of the large missions, sort of affects the cadence, yes, but not nearly as significantly as the cadence for the smaller missions. And so the decadal has a hierarchy structure of size of mission and cadence. And so the explorers are to occur on a 2 to 3 year cadence. There's only essentially three large missions in the decadal heliophysics missions in the decadal, but the cadence of the explorers is much faster. And then there are two recommendations in there in the decadal to fill in gaps between the explorers and the large missions, to have what we call a helix explorer. We nicknamed it Big X, but and so that fills a gap. But there's another very important gap down in the $10 to $35 million range, where we envision you could do constellations of CubeSats, for instance. And that cadence is on a even faster cadence than the Explorer. So the delay of a large mission, yes, it hurts, but this hierarchy of structure, as long as we can get the cadence of the smaller missions, maintain the cadence of the smaller missions, the delay of a couple of years of a larger mission is not that significant of an effect.
Significant on the team who's working on it, of course, but I mean, in terms of the big picture, but I also want to just add to that the existing assets that we have, right? We have a lot of data on the ground, and we have a lot of data being produced by both our ground and space-based facilities and currently. And so a lot of the science that we have in the decadal survey was relying on that Heliosystems laboratory as really a major part of the recommendation. So we can still do a lot of the science with what we have. We need to maintain what we have and then use the data efficiently. And then think creatively about how can we make progress towards some of the larger efforts with things like constellations of CubeSats.
Thank you. Other questions? We have 2 mic runners. Where are they?
So totally agree with the last point you guys just made. I'll just point out, and then this was in the decadal too, is a lot of the opportunities that exist for RNA hinge on using operating missions, right? And a lot of our missions, like Van Allen probes is a great example, have sunsetted, and that data is no longer eligible for like the guest investigator program. What we see in the PBR would cancel a lot more missions that would also make those not eligible for GI. So in some sense, like it doesn't matter how much data we have on the ground if there's no opportunity to actually analyze them.
Yeah, agreed, and that's actually one of our recommendations is to correct that. So there are, I mean, RESI is another one. There are some missions that have ended at this point, and the decadal survey we recommended, whether it's expanding the GI program or doing whatever, that there needs to be a program that supports analyzing archival data.
And I should point out too, in the decadal, the importance of the RNA program. What we put in the decadal was that there should be a bump up in the decadal, a bump up in this next decade of the RNA program to maintain a success rate of over 25% in the proposals, and that's averaged over all of the heliophysics our RNA programs. And so that's one of the examples of the importance of the RNA program. And again, you think about it as cadence, that's essentially on a less than a 1-year cadence for that. And again, it emphasizes the importance of it.
Riley Troyer here from Space Dynamics Laboratory. As a early career scientist, I wonder if you could touch a little bit more on, like this is for NASA, but how do the other funding agencies come into this specifically besides just being a funder of the survey?
Yeah, I mean, in a huge way. So as I said, the Heliosystems Laboratory is all of the space-based and ground-based facilities, and also the NOAA assets as well. So we do have recommendations to all those agencies. In NOAA, of course, it's directed a little bit more toward, well, it's towards space weather and operational things. We didn't make recommendations on mission concepts for NOAA because we weren't asked to. For NSF, on the other hand, there is an MREFC, which is the largest type of facility at NSF, which was NG Gong was the highest priority. There were 2 mid-scale recommendations. One of them is call it a constellation on the ground of a heterogeneous distributed array of different kinds of instruments, and we recommended doing a prototyping of that because both the ITM and the mag panels had different versions of that. So we recommended building a prototype, which is a smaller scale, mid-scale, and then that would then lead into a much larger distributed array of instruments. And there's also Phaser is a solar radio mid-scale concept. So there are recommendations as well. So the difference is really that it's mandated by Congress for NASA, but NSF, we were told as we were launching the decadal survey that, in fact, they only wanted us to recommend one mid-scale, and we ended up doing the 2 tiers of mid-scales because the community being behind the mid-scale concepts is mid-scales are competed agency-wide, so that it's not it doesn't end up in the budget of NSF in the same way that it does for NASA, but it's really, really important to show community support for those in order for them to get funded.
Other questions? I thought there was a question over, yeah. Where did it?
Now? There we go. I think you've already touched on this a little bit, but in the challenging environment that nobody's happy with here, obviously, in the spirit of adapt and overcome, what does this opportunity, what opportunities are there? Instead of the big missions, and as you put it, that hurts. They really do hurt, losing the big missions. But in the smaller sense, things that might have been overlooked or not paid attention to, do you have any thoughts about what we should be focusing on that puts us more in line for the bigger ones later? And how do we best take advantage of where we are now?
Yeah, well, so first, we need the opportunities in the RNA program. We need NASA to issue the ROSES. This is unprecedented that we did not get the ROSES issuance in February. But our field, and this bleeds over into CEDAR also, so GEM and CEDAR, our field is really well adapted for using the low Earth orbit environment to do science. And I really urge people to think about CubeSats, rockets, and balloons. As Robin has taken advantage of in the balloon program, that opportunity is pretty much unique to our field. When you look at the science that you get out of just the one rocket flight, it's extraordinary. And most of the other fields, astrophysics and planetary, they're flying rockets to test instrumentation. But we fly rockets to actually do science. And on the CubeSat side, we really feel very, very strongly that, and it's stated in the decadal, that NASA needs to review their CubeSat program, and upon reviewing it, open up the opportunity for doing constellations of CubeSats, because you can do that very cheaply. And now you can get into space very cheaply on a commercial ride. And so once those opportunities open up in the ROSES, I think that our field, we should be thinking very hard about that.
And I'll just add to that, I'm looking at Eric Donovan over here, that we have our international partners, and of course the ground-based networks, and also space-based thing. SMILE is going to launch in early 2026, which is a Chinese ESA mission. And so I think strengthening those partnerships and leveraging those partnerships, I'll just echo what Stephen said, our field, we really benefit from having distributed measurements and all kinds of different measurements, and we can do a lot. And so I think the data we have, the data we're collecting with the existing assets, then augmented with these smaller efforts, there's a lot that we can do. I think making sure we have the money to keep the people who are going to do that work, I think, is really, really important right now. And I think talking about what we can do, I think also going out and looking for other, we heard from ONR and AFOSR and the agency updates, I think many of us don't often go get funding from some of the other agencies and other places, internal funding, private funding. There are other sources of funding. Maybe we have to work harder, but I think this is a really creative and amazing group of people in our field that have really great ideas. Sometimes bad times actually lead to innovation, and I think we should, it's scary, but we need to just look for all the opportunities we can do and keep telling the story about our science.
Hi, Michael Berger, NSF NCAR over here. Not that it matters, you can't see me anyway. Robin, Stephen, I'll stand up. Hi, great. Thank you so much for all the work you and the committee did putting this together, and particularly to you two for continuing to carry the message forward, talking to Congress, talking to us, because as you say, it is a 10-year plus kind of vision, and I know we can get kind of mired down in what we're dealing with right now, but that's not going to be the pathway for forever if the advocacy continues to happen. My question to you was the one I asked actually when the first report came out, and if there's been any further discussion of the timing of the decade, right? Because it's 2023. I don't think the report made it out until much later on that. Has there been any discussion or thoughts about when the clock started or starts on that, relevant to assessing progress and being able to move forward on that front? And maybe importantly for you, how much longer you're going to have to stand up there and be the face of the decade?
Well, Abby told us years, but I mean, I have some thoughts about the decade. I think it'll depend on what happens. I don't think the Astro midterm has started yet, and it should be soon, and that's really a National Academy's agency thing to work out. It may be beneficial to delay a little bit. I mean, if we delay, we might actually slide in so that we're right before Astro, which would have some benefits, I think, so.
Yeah, it's tough. We had a lot of discussion about that, and of course, as the decadal dragged on to the extent where even we were worried. But it's stated in there 2024, 2033. That's again by decree. That's the interval, the 10 years that we have to think about. And but if you look at the budgetary process, the decadal really can't influence the budget until you get to the FY26 budget, so the budget that we're currently in. And that's why we have a full court press for talking to Congress about the importance of the decadal. In fact, we were both on the way to DC, and Robin had landed, and I was two planes behind the one that hit the helicopter. So, and we were going to talk to Senate staffers about, and the CJS committee about the decadal. So, yeah, we're apparently putting our lives on the line to move this forward. But we can't do it without you. And so I can't stress enough to contact your representative and tell them how important our science is, and how important our science is combined with the space weather aspects of this. You really don't advance one without the other, and that's a very important message to your representatives.
Thanks. I wanted to follow up on Robin's comment about the international landscape. And one thing I wanted to remind my American colleagues here, that in Canada, for instance, we look to the US plans, right? And we actually build what we do around a lot of what the US does, of course, right? And so from our perspective, it's very important that the decadal plan remains the decadal plan, right? That those science questions remain the science questions of focus. And I think from your perspective, that's also important because we will keep going in that direction, which I think helps you leverage in the future. Say like, well, the rest of the world's going the way we said, so we should keep going the way we said. But the other thing is that when you have the big missions, like GDC, then we tend to write proposals that are this, if we do this thing, it will fit into GDC, right? And if we do this thing, it will fit into, links, right? And it will support links in this way. But if you pull GDC out and links out and so on, then you still have the science questions. And I think then the strategy is to think, what are the mid-scale things that we can string together, right? Rather than say, we pick this mid-scale because it supports GDC and this mid-scale because it supports links. Well, let's do these 3 mid-scale things together with this thing in Canada and together with Aurora D in Europe. And that will allow us to address this thread in the ITM plan, right? Which is a very different way of thinking, and I think, I wouldn't say equally valuable, right? We're not going to get as much for $200 million as we would for $1 billion, but we'll get something, and we keep moving in the same direction. And so learning how to strategize and daisy chain together smaller things to address threads that are identified in your plan. That's what I hope, that's the strategy I hope people settle on if the big things are really going. So.
Yeah, I'll agree with that completely, and I'll also just echo that we all know that when we make new measurements or we do anything, our questions evolve, right? We learn things, and look, a links mission might actually look different after we do some small things that we relearn a lot and say, no, actually, we really should put the spacecraft here, or in this configuration. And so it's really valuable to do the smaller things to work towards the bigger things, even if they get pushed out. And look at Parker Solar Probe. I mean, I think that was recommended 2 decadal surveys ago initially. I mean, it's not uncommon for...
1964.
Okay, the original Parker Solar Probe was 1964. I mean, it's not unusual for it to take decades to realize these large mission concepts. They're big efforts, and everything that we do, working towards them is laying the groundwork to make sure that those missions are the most scientifically valuable things they can be.
Yeah, and if you look in the decadal, this DASHE concept is a really good example of what you were just talking about, and that is that it's a distributed array of heterogeneous measurements that it's distributed all up and down the Americas, including Canada, including South America, and it's very important to get that latitudinal distribution. That's a very important element of that. And so joining in, and frankly, that's one of the reasons why it was selected, was the international nature of it, the heterogeneous constellation nature of it, the fact that it did unique fundamental science, but it contributed to this larger heliosystems laboratory. Those were all things that made that particular mid-scale project percolate to the top in the recommendations.
Yeah, Bob Isaac here. One of the things in the president's budget that I thought was particularly egregious was the zeroing out of support for STEM education and outreach. Now, I'm not sure if that was really part of the purview of the survey, but have you discussed anything about that and what we can do to, number one, educate our future generation, and number two, educate the public about the importance of our research?
It may have been brought up in discussions with congressional staffers. Space grant is really important across many of our states, maybe all of our states. So that was definitely, I don't think the cuts of that had anything to do with science, I'm not sure that even Congress understands what that Office of Engagement does and what it supports. So continuing to tell people that, I think it's just a lack of awareness of what those programs do. I mean, they support, for me personally, undergraduate and graduate education. Students can go do an internship that they don't have any funding for example, or work with people at the university. I think we just got to get that message out. It's not very expensive, and it's critically important, and especially particularly for the small states that don't have a lot of resources. So, in terms of state funding for the universities, so tell anyone you can, your representatives. Go visit Washington, tell them your story about the importance of those. I mean, I personally, benefited from a young scientist space grant funded position at Dartmouth, and that's how I originally got there. And so I tell those personal stories to whoever you can.
Yeah, and I should say one of the things that resonates very, very well with congressional staffers is to make the argument that what we're trying to do is build the workforce for tomorrow. There's a quote in the decadal from a representative from I think it's Lockheed Martin actually, that says that whether they know it or not, every company in the future is going to become a space company. And so what we're trying to do here is build the workforce for tomorrow, not just the scientists and engineers that are working directly in space, but everybody. The good example is the Gannon storm, the Mother's Day storm of last year, the precision GPS that people in Iowa and the Midwest use, farmers in Iowa and Midwest use to plant their crops. They couldn't use it because of the disturbance in the ionosphere, and the estimate loss was $500 million. That's a lot of money, and so whether they know it or not, these farmers have become a space company, and they rely on space assets, and so it behooves us to train the workforce for tomorrow, and that's starting all the way down in the grade school level, all the way up to graduate level.
I think that we have a Slido question. Who's monitoring the Slido? Let's ask those.
Hi, Robin and Stephen. It's so nice to see you here, and thanks for coming here to talk about the decadal survey. So there's a Slido question here. The first is, only in Voyage 2 visited Uranus and Neptune. Under this new budget situation, does it mean we won't be getting any mission there in the coming decades?
I would hesitate to say that we wouldn't get one in the coming decades. It might be delayed, and it most likely is going to be delayed given the budgetary pressures. But I still, again, this is the power of the decadal surveys. In the Planetary Decadal Survey, they have said that is their highest priority. And after MSR, yes. But take a lesson from the astro decadals. They said that JWST was their highest priority, and they had to say it for 3 decades, but they finally did achieve it. And so it's sticking to the priorities. And that's why, by the way, GDC is in this decadal, it was the highest priority mission after IMAP in the previous decadal, and we were told not to prioritize it, but we didn't have to prioritize it because it was already a highest priority. And so it's a matter of sticking to the science.
Yeah, there's one more question. Okay, so what opportunities does the decadal survey offer to retain early career scientists? What message do you have for those whose funding is ending very soon?
So the purpose of the decadal, unfortunately, is not directed in that way. We can in the decadal recommend to Congress, to recommend to NASA to do certain things, and one of the most important things that we have recommended is an augmentation of the RNA program. And so for early career scientists, I remember this myself. That's how you get into this field, and that's how you get to a chance to progress is through the RNA program, to make a name for yourself through the research grants that are available. And we've recommended that they increase the success rate to 25%. And the reason for that is that 25% is sort of a number where you can see that there's a healthy community. And yes, you do select the ones that are the proposals that are most likely to succeed, shall we say? But you also have the opportunity to select some innovative ones, some new ideas. And so I would recommend, if we get, when we get a ROSES announcement, focus on those RNA programs, and again, go to your Congress representatives and argue for this funding, this entry-level funding.
Okay, time for one more quick question.
I'm actually going to jump in here. I've been standing and waiting. So, Tony Rogers, early career scientist. One big concern that's been coming up over the course of this week, and it ties back to, Robin, something you said a little bit ago, all of the data we already have on the ground, sort of the archival data. We already know that funding for this can disappear with very little notice. We already lost all the ionosphere data from NOAA, and it was only the work of a handful of private individuals racing to get personal hard drives. And even now, that data, although it may have been saved from being lost from NOAA, is in the hands of private individuals and not terribly well organized. Does the decadal survey, as it stands in this form, does it address any of the question of maintaining that kind of archival data and for protecting the data from future missions so that it can still be analyzed?
Yeah, I mean, there's a very long recommendation in the section on Drive Plus that talks about, it's called really cyber infrastructure, but it has many bullet points for the different agencies, and we really leaned on making use of the existing archives. Of course, we didn't imagine that archives would be disappearing, but you know, some way to, I mean, NSF has a cyber infrastructure program, and so applying to that, the community needs to organize those efforts. It needs to be a community grassroots thing, but I mean, coordinating that and making sure we're not having 10 different groups doing the same thing, I think is really important. So whatever the community can do to try to coordinate those efforts and then try to seek funding from, for example, from that NSF program. But the recommendation as we wrote it is really about all the agencies working together and coordinating to make sure we're able to access data that's ground-based, space-based, NOAA data, all the data. I think if people are holding archival data right now, I mean, just like, let's first protect the data and look for ways to try and then distribute it more effectively.
Thank you. And thank you all for asking a lot of great questions. If you didn't get to ask your question, please see Robin and Stephen afterward. Please give them another round of applause. And we need to move on to Shasha So, who's going to give us an update on the Living with a Star Program Analysis Group and the Living with a Star Focus Science Topic solicitation for 2026.
Good morning, everyone. And first, I want to thank Lin and Lin. You were able to accommodate my last-minute requests. Okay, so we need your help. I'm here on behalf of the LPAC Executive Committee. So I'm one of the co-chairs of the committee. The other co-chair is Angelos. And we have a fantastic team here as well. So some of them are here right now or were here this week. So let's see. Yin Cohen, if I say your name, if you are here, please stand up and wave to everyone. I know Yin, you are here. Chen Feidong, Dong Lin, Tom Imo, Steve Kepler, and Bob McRoy, I think all of the members are here that I just said their name. We also have several solar folks. They are in the Shine workshops this week. So they are actually giving exactly the same presentation that I'm giving here. Okay, so since we have students and an early career scientist here, I want to spend a couple of minutes talking about LWS as one of the programs under the heliophysics division at NASA, and then I want to talk about what LPAC's task is. So the NASA LWS program has a strategic goal to develop the scientific understanding necessary to effectively address the aspects in the Sun-Earth system that directly affect life in our society. So in a short word, this is the science-driven portfolio that directly to applied research, okay, or the science behind the space weather. So we, the LPAC Executive Committee, is the bridge between the LWS program lead at NASA and every single one of you. We treat every single one of you as a member of LPAC. One of the tasks for us as the LPAC Executive Committee is to collecting and reviewing the ideas from the community for focused science topic, and that is what I'm going to talk about today. There are other topics in the past, strategic capabilities, tools, and methods. Those ideas are all from the community. So we as the executive committee work directly with the LWS program lead, John McCormack, and his team. So we make sure that the communication between the community and then the LWS programs is smooth. Okay, so every year, NASA sends out the call for LWS focused science topics. That is part of the ROSES element. The LPAC Executive Committee is beginning to develop the next round of input for LWS FSTs for ROSES 2026 and beyond. It is extremely important that we have the active community input to send us your ideas, because the costs that are included in the ROSES solicitations, those topics are from you, okay? It's not from the panel, not from the LPAC Executive Committee, but from our community. So this is our new LWS Science Program website. When you go to that website, you will be able to find more information about LWS and the 10 strategic science areas. When you click on one of them, you will see the details. So when you think about your ideas for this FST, you can think about how you can align them to the existing strategic science areas. It goes all the way from solar dynamo into planetary habitability. So it's a really broad areas. Now, on the website, you will find a place where you can submit your ideas. The deadline is roughly in a month, July 24th. After we collect all your ideas, the LPAC Executive Committee will review, consolidate, and then format all the received ideas into a more uniform format. And then we will send them out to the community again to get feedback. In the past, I think the last call was maybe 5 or 6 years ago. We get a lot of good ideas from the community. Many of them have been selected, for the Rosas in the past several years. There are some leftovers. They will still be considered. However, you listen to Robin and Steve talking about the new decadal survey, and since 5 or 6 years passed, it is a good time for you to look at those topics and then think about what has done in the past 5 years, what hasn't been done, and think about how to improve it or better align it with the decadal, better align it with the LWS strategic science goals, right? It is a good time to update them. Okay, I learned how to make a QR code in this meeting, so I put a QR code there. So if you scan, you can directly go to the website. There are more information there. Besides strategic science areas where you can submit focused science topics, you can also find our annual report. So LWS Executive Committee summarizes the findings and analysis activities every year and writes them up as an annual report directly sent to the LWS program lead and the heliophysics division director. Okay, so if you have a good idea that you think will be useful to help address the strategic science goal of LWS, if you have a science idea that you want to see it in the Rosas solicitation, please submit your ideas. Okay, thank you.
Any questions? No? Okay.
Yeah, so feel free to talk to me or any of the members. Okay, if you have any suggestions or comments. Thank you.
Okay, thank you. All right, the plenary will end with some closing remarks. And then that will be followed by some breakouts. Don't forget to come to the town hall lunch advocacy session that Ian Cohen is leading. So I hope you had a good meeting. I'm sad that it's ending and also relieved. I've just loved this venue. It is so glamorous, and I found Des Moines to be pretty charming as well. There are these interesting murals all around.
All right, so this is just a reminder of our attendance and some statistics from this week. We had over 264 people at GEM and over 344 in person from CEDAR for a total of over 600 in-person attendees. I definitely felt that at the banquet last night. We had over 400 posters and over 170 supported student and early career scientists, which I think is wonderful. Thank you so much to our sponsor, NSF, for allowing that to happen.
So in terms of CEDAR, the CEDAR Science Steering Committee membership update, we've got members rotating off on the left and members rotating on the right. Our new members are shown here. We welcome Brian Harding, Pavel Inchin, Shen Liu, and Bryce Halter will be our new student representative, replacing Sophie Phillips. We want to extend a huge welcome. Mark, please come up to the stage. We're so appreciative. We're so grateful for all that you have done. Mark has served the CEDAR community for the last 3 years, and he will continue to support the community in so many different ways, and his unwavering guidance, hand on the helm, has been so appreciated. We just have a small token to show our appreciation. Thank you so much, Mark. Please give him a huge round of applause.
But before you leave, I also wanted to just make a comment that the reason we're all here today, we have to thank Mark. So I remember 2 years ago, I was at the CEDAR banquet in San Diego, and I walked up to Mark to just introduce myself, and one of the first things he said was, you know, I've been thinking, it's been a long time since we had a CEDAR joint meeting. I think we should really make this happen. And I was like, whoa, it sounds like a lot of work, but he has great enthusiasm, and this sounds like it could be a really awesome thing. And so, as he always says, it takes a lot of people to put it together, but we really have to point to Mark because he's the one who sparked this whole awesome idea to be here this week. So,
thank you so much, Mark.
I'd just like to say, you know, it's been an honor and a privilege to serve as the CSSC chair and to work with Jem to get here. And I've said to lots of people this week, when we started out with this, I was terrified that the cultures of CEDAR and Jem would be so different that we'd get a couple of months into it and we'd all end up in a big fight and just give up. And that is absolutely not what happened. Both of the communities worked so hard, and everybody who was in that room was working just to make a good meeting for everybody who's here. And it was a complete privilege. I think I got to see my colleagues at their best, doing what they could for the community. So it's been fantastic, and thanks to everybody who's here and everybody who made this happen. Thank you.
So that leads us to the GEM steering committee members who are rotating on and rotating off. We have rotating on Wen Lee, Anton Artemiev, Catherine Davidson, Kevin Pham, and Mary Smirnova. And we also have rotating off our organizers, Chris Moikis, Jing Liao, Austin Smith, Kevin Genestretti, Sarah Vines, Linjin Chen, and Ian Cohen. So if we can welcome and say thank you to those two groups.
So if you look way back to Monday, the meeting kicked off with CEDAR's most distinguished prize, this distinguished lecture, and Phil Erickson gave a wonderful talk that spanned both CEDAR and GEM science. Congratulations, Phil.
Also on Monday, we had Blair Schneider with Advanced Geo, who spoke to us about building a safe workplace climates and safety in the field.
On Tuesday, on the CEDAR side, we heard from our grand challenges. Jens Oberheide spoke about lower atmosphere impacts on the IT, Titus I, gravity waves in the IT, and our newest grand challenge, Leslie Lamarck, talked about polar cap patches. We welcome those efforts. As well as the science highlights that we heard. Kamal Kumari gave the early career science highlight on stratospheric warmings and geomagnetic activity interactions. and Bill Schwartz presented a highlight on the recently launched and exciting EZ mission.
On the GEM side, we had our new focus group leaders, Harriet George, Yi Chi, and Savas Raptis, who gave tutorials on their particular research areas. And we also had on Thursday the student-invited speaker, Tony Rogers.
On Tuesday, the day capped out with the excursion, and over 50 of you joined us. We are now known as GEMDARs. It did not rain despite the previous 36 hours being nonstop rain. The Iowa Cubs lost 12-0, but we had an absolutely fabulous time. How do we play the movie?
Oh, I need to ask them. Could we get, can anyone help us play the movie? Do you have control over that over there?
The lower right, there we go.
Thank you.
There should be sound. That whole section is us. It was a wonderful time.
We had some really successful community organized events. Queer Beers had over 80 folks go out to celebrate together. And the hobbyist lunch was also super fun. We have a photo here of all the people who gathered for lunch to talk about their hobbies. So thanks for organizing those events.
Moving on to Wednesday, we heard from our agencies. Most of our funding agencies were able to give updates, and both Tuesday and Wednesday hosted student poster competitions in a space that was spacious, catered, and lively.
And we just want to say once again, congratulations to all of our student poster winners who did a really great job presenting their work. I had a great time, I know, going to see a lot of posters this week, so thank you all the students who put forth so much effort.
Another very prestigious award that CEDAR gives out is the Prize Lecture, and congratulations to Jens Oberheid, who gave a wonderful CEDAR Prize Lecture on tide and planetary wave coupling of the lower atmosphere to the IT system. We also heard more science highlights from Zhijun Zhao on wave modulation of the MLT, and Jia Yu on lower atmosphere impacts on satellite drag, a very timely topic.
We also had a really great session yesterday, thanks to Dr. Rebecca Pope-Rourke, who helped us identify and mitigate burnout. Last night's banquet was elegant and wonderful, and it was also a hoot. So thank you to everyone who participated.
So the CSSC works hard to make this meeting meet your needs, and we always value your feedback. If you have not yet done so and you want to put a suggestion in the suggestion box down by the registration booth, we welcome you to do that. Specific feedback that we've heard so far is having the posters up all week has been wonderful, and the poster space has been really enjoyable. Overall, the venue is really nice, although the ballrooms may be too big for breakout sessions. The AV support was top-notch. We actually got that feedback. You guys are awesome. People did not appreciate being charged for water during the poster sessions, despite hors d'oeuvres being walked around. Maybe the breakout session instructions could be improved. The excursion banquet and entertainment were a big hit, and everybody seems to be in favor of an in-person meeting next year.
So this in line with the feedback, there was an announcement that a task force has come together who want to compile a list of students and early career folks whose funding will end within a year. The idea is to create a centralized list of people looking for support in case there are grant holders that could have a means to contract them. So just know there are folks that are brainstorming ways to try to connect people and support people in the field. If you are in this position, feel free to use the QR code to scan. I'm sure there will be GEM Messenger and CEDAR newsletters announcements going out as well, but just wanted to kind of put you on notice that this activity is going on.
And so just a few words about the future. Next year's workshop, as you all are well aware, NSF is facing potentially significant budget cuts that will likely impact our programs and our annual workshops. But I assure you that the leadership and steering committees are committed to working together to host an in-person CEDAR and GEM meeting next year, regardless of the level of NSF support. I personally have already identified one option that would allow for a bare bones meeting with little to no upfront funding. We also look for creative solutions to hold inexpensive workshops if necessary, and we will be soliciting you for input through online surveys indicated by these QR codes and others that will come out. We will communicate your feedback to NSF. We will use your feedback within our steering committees to make strategic decisions, and we will work together within our communities to continue these programs in some form. We will face these difficult decisions head on, and we will get through this.
And I just wanted to add a few comments to that, yeah, coming into the meeting, I wasn't sure, I mean, I know we all love CEDAR and we all love GEM. I wasn't sure though, like where the pulse would be as far as an in-person meeting next year. We obviously have a lot of uncertainty as far as funding goes, but almost everyone who came up to me was very enthusiastic about having a meeting next year. And I think it wasn't just about, it's not just because CEDAR and GEM are an amazing place to share our research and disseminate it as our funding agencies ask us to, and to learn and collaborate. It's also just a place that we really connect and support each other. We find just a lot of friendships here and a lot of collaborations, and I know it, as I think, was it Mark, it felt like the tenor here was, obviously we all have an undercurrent of uncertainty, but I think I appreciated sort of the uplifting feeling I got by being with you all, people who I consider not just my work colleagues, but also my friends. And so hopefully we can continue this sentiment next year as well.
So we are going to conclude with just some thank yous, first to our student representatives. Both on the GEM and CEDAR side, you're absolutely outstanding and continue to impress us with all of the work that you do for the community.
And I just want to say a personal note, I really enjoyed getting to know these students over the past year because we had these weekly meetings, and they're really awesome people, so I hope you all can get to know them better too.
I'm not going to go through this list completely. There are too many people to thank. We thanked some of them already, but they're all listed here. This is how we make the meeting possible. We do want to call out the people involved with the GEMI program.
Yeah, we should have asked them to stand last night at the banquet, and that was my fault. So actually, Fraz Bashir and Kareem Sarathia, if you're in the room, do you mind standing up so just we can thank you, because we know the GEMI program took a lot of work to put together. We can thank them anyway. Maybe they could be online too.
It really takes a village, from the meeting organizers to all of you, to the steering committees, to the venue support. It's an incredible amount of work, and we're really glad that you're all here and hope that you enjoyed your week. And we will see you next year.
In 2026.
We're going to release you to break early, unless somebody has a question on the closing remarks. Okay, thanks, everybody.